I do like to, on this topic of uniformity, to parse the problem into two parts. And one part is uniformity among batches. And so that is, this morning versus tonight, or today's morning versus tomorrow's morning versus the next morning. They may not be uniform even on average if the person loading the mixer doesn't get exactly the right amount according to the recipe.
Welcome to the Feed Science Podcast. I'm Adam Fahrenholz, coming to you from North Carolina State University in the Prestige Department of Poultry Science and with the Animal Food Manufacturing program here. On behalf of WiseNetics, thanks for joining us. We've got two guests joining the podcast today. Both are from Purdue University. We have Dr. Jacquelyn Boerman. She's an associate professor in the Department of Animal Science, and Dr. Dennis Buckmaster, who is a professor in the Department of Agricultural and Bioengineering at Purdue. Jackie, Dennis, thanks for joining me.
Thank you for the invitation.
Great to be here.
Yeah, absolutely. If you guys wouldn't mind, and Jackie, we'll start with you. Looking at my screen here, you're on the top window, so you get to be first. If you wouldn't mind, introduce yourself a little more, what your background is, and what you're doing there at Purdue, and then we'll follow up with you, Dennis, as well.
So my background is I'm originally from New York, and I grew up on a dairy farm. And then I went to graduate school at University of Illinois doing dairy nutrition, and then a PhD at Michigan State also doing dairy nutrition. After graduating with a PhD, I worked for Cargill Animal Nutrition for a little bit, doing technical consulting. And then I have been at Purdue for about 7.5 years. Working mostly in dairy nutrition and management, research, extension, and teaching.
Gotcha.
All right. Well, I grew up in Northeast Indiana on a farm. We also had a short line equipment business. And interestingly, that was all about livestock feeding systems, silos, conveyors, TMR mixers, and things like that. So I'm an ag engineer from Purdue, went to grad school at Michigan State. And the first half of my career was at Penn State University, doing primarily forage systems work, including harvest, storage, and feed delivery, TMR, particle size, things like that. About halfway through my career, I moved to Purdue, so I've been here just almost 20 years now. And here the focus a little bit the same, and then sort of made a hard turn toward things in digital agriculture. And the work that Jackie and I are doing together with some others, sort of a kind of a unique blend of forages and feeding and digital ag. So really excited to be involved.
Excellent. Yeah, that's we've got, sounds like we've got a great kind of breadth of expertise here from the animal feeding side and backgrounds all the way going back to farming and equipment and digital and dairy, and so we should have a great conversation. I think what we're going to spend most of our time talking about over the next 20 minutes or so is what we do at the TMR. And so we've got a number of different folks that listen to the podcast. And, we know that we have folks that are listening that are in the typical compounded feed mill type of industry or academia. We've got folks that listen that are involved in liquid feeding and premixing. And we have folks that are doing things related to the feeding happening there at feedlots and at dairies using the TMR. So if you guys wouldn't mind, and Jackie, I guess we'll let you do this. If you wouldn't mind describing to our audience just briefly what the TMR is for those that might not live in that world.
I'll start, and then I know Dennis has a lot of experience with this as well. But TMR stands for Total Mixed Ration. So it's going to be a combination of forages and byproducts, minerals, grains, etc. And dairy cows are going to be fed a TMR every day. So most of the time with our high producing lactating cows on an as-fed basis, they're going to be fed well over 100 pounds, and some may be approaching 150 pounds of feed that they're being fed. So because it is this combination of so many different ingredients, that's really why we want the cow to be able to consume the same ingredients and nutrients for each bite of feed she's consuming. So that's kind of why we're leaning towards evaluating uniformity of that TMR.
Absolutely. And Dennis, if you wouldn't mind, describe kind of what the actual the physical nature of what a TMR is doing versus, kind of our inside a feed mill feed mixer type of a situation.
Right. So in the TMR, because we have forages and concentrates, there's a large variation in the sort of the structure and the feel of those components, the length of the particles. In some TMR mixers, you toss an entire large round bale in there, and the mixer is supposed to chop it up into appropriate sizes for the cow to consume, and at the same time, like mix it perfectly, or at least near, at least uniform enough. So you have some feeds in that ingredient blend that are very dense and small particle sizes, and you have other particles in there that are relatively light and fluffy. And so there's a term called overmixing. I don't know that I really like that one, but like you can do too much. You can reduce the particle size too much. And so, from the nutrition aspect, we need the right physical and chemical traits in each of those bites that Jackie's talking about. Well, at least within the meal, we want the right blend chemically and physically there.
Yeah, you got. Yeah, I'm already enjoying this. You're talking my language. When I hear someone say they don't really like the term over mixing, I get excited because I hear that one too. But of course, as you pointed out in the TMR world, the mixer is also kind of a processing machine as well. So in theory, we could over process. We're probably not unmixing by over mixing though, which is certainly important. And then also that idea, because we talk about this with the different species, and we've talked to folks here on the podcast that do poultry and swine and multi-species and dairy cattle, and we talk about uniformity and the fact that nutritionally speaking, uniformity is important. We want good uniform feed, but we can be a little different if we're talking about a day-old chick eating grams of feed and a lactating dairy cow eating hundreds of pounds or 100 pounds worth of total thing. Okay, we don't have to have exactly the same amount of uniformity there, but knowing that we want as much as we can reasonably get, why does the uniformity matter to the cow? And I know, Jackie, you already talked about it a little bit, but a little bit more from a nutritional perspective. What are the problems if she's not getting a uniform feed?
Yeah, so for this dairy cow, which we're expecting her to do a lot for us, so she's producing high amounts of milk, and from as a nutritionist, again, it's not a chick that's eating just grams, but we are balancing some nutrients at the gram level for her. So those ingredients are going to be really expensive. So they're things like rumen protected amino acids that we want to make sure that every cow is getting a similar amount, or at least based off of her intake, a similar amount. And that's going to have an effect on things like her milk protein output, or milk fat, or just milk in general. So we want to make sure that there is uniformity. We're also a lot of times feeding the rumen. So we want consistency in that rumen environment. We don't want a lot of variation to occur, so that the outputs from the rumen, like volatile fatty acids, like microbial protein, are consistent throughout the day. This cow, we're asking her in some cases to grow, but we're definitely asking her to produce milk every day, sometimes to also grow a calf. So there's a lot of things that we're asking her to do every day, and she needs to have consistent nutrition in order to make that optimal.
Absolutely. So we've talked a little bit about the different ingredients and the forages and whatnot, and you talked about something there that we are concerned about, like you said, down on the gram level, some of the additives. Those additives are generally going to come as part of like a larger supplement, right? Where we're going to have a supplement that contains a lot of our expensive additives that we're buying from the feed mill or we're manufacturing at a different location. And then we're combining that grain supplement with those additives and whatever else with what else in the TMR.
A lot of times that's going to be like a carrier, like some corn grain or soybean meal, that is going to add the mass that you need really in order to mix appropriately. But something that is a little unique on the ruminant side is that we're doing the mixing at the farm. So every day, a person is out there mixing multiple diets for cows. So we don't have maybe the expertise of someone who's working at a feed mill and has the training and has the equipment um, to make sure and is doing quality control on how uniform they're doing, because we're doing it on farm. And it's every day, but there's not a lot of tools in place for them to evaluate the performance that they're getting out of the diets they're mixing.
Absolutely. Okay. So with that in mind, knowing that we want to have as much uniformity as we can reasonably get with the equipment we're using, the amount of time we have, and the ingredients that we have at our disposal, and knowing that it's being a lot of the mixing that's happening is being done on farm, bringing in supplement, adding fiber sources, adding forage sources, maybe some energy sources, etc. How do we, at least currently, commonly evaluate the TMR and to know whether or not we're doing a good job mixing?
Okay, I'll take that one. There would be several ways to do it. There are sort of research standard methods of putting a particular chemical or a salt in there and taking samples and then calculating uniformity by standard deviation or coefficient of variation often. I do like to, on this topic of uniformity, to parse the problem into two parts. And one part is uniformity among batches. And so that is, this morning versus tonight, or today's morning versus tomorrow's morning versus the next morning. They may not be uniform even on average if the person loading the mixer doesn't get exactly the right amount according to the recipe. But it's not always their fault either, because primarily those forages might vary, particularly silage out of a bunker silo, depending on the climate. If it rains or it's been hot and dry, the moisture content of the forages can change from day to day. And so because these rations are balanced on a dry matter basis, but it's mixed on an as is or wet basis, depending on the talent or the aptitude of the person doing the mixing, they may make some adjustment that's approximately right. They'll never do it perfectly right because they can't get data fast enough. But that is one of the sources of variation. So we would at least be able to evaluate the among batch, like, is the person who's doing that job being conscientious? And if it calls for 2,000 pounds of this, did they put in 2,000 or 1,800 or 2,050 or something like that? So that's one. The other one would be within batch variation. So even now I've put the things in this blender, this mixer, and if I don't run it long enough, well, then I'm going to have hot spots in energy or protein or that sort of thing. If I ran it too long, as you mentioned earlier, I might process that forage and cut it up a little bit too much. Well, there is going to be some time that's sort of the sweet spot. It's been long enough, go ahead and deliver it. Don't waste any more fuel and machinery maintenance by running the mixer 20 minutes when 10 minutes would have sufficed. Also waste labor, like who wants to do that? So the uniformity within the batch, I don't know that many, there are some companies and consultants who would facilitate that analysis, but I don't know that universally farms actually do it. But certainly one way that we'd advocate doing it is the particle size analysis. It's a very physical thing. Take a sample, shake it out, weigh some masses, and you see it. Even if you don't regularly analyze uniformity, it provides a teachable moment regarding uniformity.
Again, my guests today are both faculty members at Purdue University, Dr. Jacquelyn Boerman and Dr. Dennis Buckmaster. All right, so I think we've done all of that in the first half of our discussion to get to now the second half of the discussion. Would you guys like to describe the project that you're working on using digital agriculture, video analytics, things like that, to figure out if there's a way that we can kind of in real time measure and report out on this TMR uniformity?
Yeah, there's really three objectives that I think we can talk about here for the project. And the first objective is to evaluate that uniformity. So we have a project where we have cameras mounted above a mixer wagon. And then before the mixing process starts, we are taking video of what it looks like in the mixer wagon. So it's directly above, looking down at the contents of the mixer wagon. And then after it's been mixed for half of the duration that it's supposed to be mixed, we stop the augers and we look down again and we evaluate the uniformity. And then at the final, before it's being fed, we evaluate the uniformity again. How we're evaluating uniformity is we're selecting 100, it could be 1,000, it could be however many, but we're selecting regions of interest within the mixer wagon. And we're saying, are these regions similar to one another or are they different? So we're doing every comparison between all of the regions. It results in a lot of data. It results in like a lot of data to then analyze and figure out what to do with. And we're working on this project in conjunction with Dr. Amy Riebman, who has the video analytics expertise. And then we have a student who's gaining a lot of that skill set as well. But so that's one of the projects that we're working on to try to evaluate uniformity again within that mixer wagon. And one of the key things that I think we're trying to do that is difficult to achieve is giving information to someone before it is unloaded, because there's not a lot of information that the farmer can have before feed is unloaded. So it's from that perspective of above looking down. And we're comparing it to some of the measurements that Dr. Buckmaster already talked about particle size distribution and the individual nutrients across a feed bunk. So that's kind of our comparison. So another project that we're working on is also with video and trying to use a different video camera to predict how much feed cows are consuming. So that's somewhat related to this as well. And then the third one is really more of Dr. Buckmaster's expertise about integrating all of this data, because we know that dairy farms are creating a tremendous amount of data, and our project is creating even more of it for them. So we need robust tools in order to be able to pull in this information so they could have access to it in a meaningful way to make decisions.
Excellent. So, what then, Dennis, are the challenges with that integration and pulling all that data together? We talk about similar things about in the feed mill side of, okay, we've got a potential very significant big data source if we wanted to measure everything. And in some cases we can, in some cases we can't. But the question still remains, well, what are we going to do with it anyway? And I imagine that's the challenge here as well.
It very much is. So I'll start with the end in mind. The goal here is if we could know on an individual animal basis how first that we delivered to her bunk, a uniform blend and how uniform it was, that was part of it. If we could know on an individual animal basis how much she is eating, when she is eating it, then we can tease out behavior. We could, sort of check off some anomalies, like this cow usually eats this much by this time of the day and she didn't. Like, I'm not really worried yet, but then it gets to tonight and she still hasn't. Okay, maybe there's a time for an alert to fly, via text or email or something like that. So that's one of the elements. The other one is really feed efficiency, feed conversion efficiency. And, as Jackie mentioned, of course, they're producing milk, but it's not just feed to milk, because depending on their stage of lactation, they may be growing a calf or recovering some body condition. So in the whole of it, we would want to know exactly how much did she eat, exactly what did she eat, what is her rate of gain, not necessarily by the day, but this week or this 2-week period, how's her body weight changing? What is her milk production by the day? Because in that instance, if there is much of a change day to day in milk production, that should kind of raise flags like something is up here. Well, that data comes from assorted sources, and even in in what we now have as a Purdue Animal Sciences data ecosystem, there are multiple pieces of software that collect different aspects of the dairy data. Could be a tracker on her anklet, could be a chewing monitor, can be these video cameras that we're speaking of, certainly the milk production by the quarter, by the milking event, morning, evening, or even 3 times a day. The integration of that data, particularly when you want to get it to the individual animal level and to be able to do some calculations about number 17 and number 18, this is complex. I like to use it's a silly quote, but there are many variables in the equation of life. Well, there are a lot of, we're talking about the life of a cow, and there are so many variables. Some of them, we wouldn't necessarily need by the minute, but actually knowing the environment, the temperature and humidity in the barn, that can give me insight as to why the whole group ate a little more or ate a little less today. And so on one hand, we would want to know individual animals, but they are a part of a group. And what's the group doing? All of this can, in the end, give us insight of, they consume more or less than what we expected, maybe because we changed forage source, like we switched from one silo to the other on that day. Well, that's helpful to know. So now I'm not worried about a disease or sickness or something like that, because, it is what it is. And maybe next time we'll adjust in a more smoother transition instead of an abrupt change in feeding, like all those kinds of things. So the challenge is the data integration, because the data is coming from different platforms or sources.
Deep in the jungle, nature holds the secrets to healthier, happier chickens. Science is unlocking those secrets with Optient, the revolutionary lighting innovation for poultry farming. By mimicking nature, Optient gradient lighting creates a unique floor-level lighting gradient that improves feed conversion by up to 4 points, slashes energy use by 70%, and keeps flocks calm and stress-free. That means better animal welfare and a more efficient farm. Want to learn more? Optient gradient lighting is now available exclusively through your local Valco dealership, or email optient@val-co.com today.
What are you guys specifically finding also about using video analytics in this case, as far as I'm thinking both the environment it's being used in, as well as what we're trying to look at, and I've got in my mind, and I'm no expertise on any of this, but I've got in my mind the fact that, okay, we're going to be outside, we're going to be dealing with dust and rain and environmental conditions like that, and we're also dealing with, it's not like we're mixing bright red basketballs and bright blue marbles. We're doing relatively small stuff, and it's all going to be some sort of a natural shade of yellows, oranges, greens, browns. So what is that process been like, trying to, I suppose, train the systems on what they're actually looking at?
I think that when we started out, we write a grant and we have all of these ideas of what is possible. And then you get the data and you're like, oh, you learn a lot as you access the data. So and it's really been a lot of expertise of Dr. Riebman. But what we've learned is that there's different color spaces that we can explore. So some are going to be a little bit more sensitive to things like shadows. So maybe we should avoid that color space and go towards one that shadows and lighting conditions have less of an effect on. And you're right, it is brown and green in color a lot of times. So we're initially looking at the pixel intensity. So we are going to look at color from on a spectra and then figure out where it's falling. But there's been some other instances where we're exploring like maybe some different things, so different next steps. And we've been working with Diamond V, who has quite a bit of expertise in this space of doing TMR audits as well. But we know that one of the issues with mixer wagons is that maybe they're not run at a high enough RPMs to get the augers moving fast enough. So feed just kind of sits and stirs rather than mixing. So there could be places in the mixer wagon that are going to be more critical to evaluate than the overall mixer wagon. But yeah, we're learning a lot. Dust, manure, all the wetness, like all of these things aren't great for video cameras. But I think that there's some tools that we can utilize to try to minimize the risk for that. And we really are relying on a lot of expertise from people who have done video analytics for a long time.
Just a wee bit. We're trying to keep this certainly on the affordable range. So we're using red, green, blue cameras. However, for those that are familiar with imagery analysis, there are things called multi-spec or hyperspectral imaging. They can actually see layers of color that the human eye can't. And so there is a potential that hyperspectral would tease out, what is really different about a piece of soybean meal versus a part of the corn stalk that is, to me, looks to be the same color, but maybe hyperspectrally it's quite different. So we haven't pursued that just because as of today, it's pretty cost prohibitive. Like we could do it in research, but we want this to be practical on the farm. And at least at the moment, I don't know that hyperspectral imagery would be practical on the farm. But it also does hold potential. Like let's go back to forage harvesters now, at least one brand, can give you nutrient analysis on the fly while you're chopping the corn silage or the alfalfa. How are they doing it? Hyperspectral imaging. So it's back to a few decades ago, NIRS, near infrared spectroscopy. That's the sort of thing. Well, maybe it will someday be practical because not only can I say, yep, it's uniform, I can also know, and this is the net energy of lactation. This is the degradable crude protein value of what we're going to put in the bunk in 5 minutes.
Yeah, no, I think that's an excellent set of points because, and for the audience that's familiar, you mentioned NIR. We've gone in the feed industry from, okay, NIR was obtainable only by so many, and it was only benchtop, and then it became more obtainable on the benchtop by more and more folks, where we see it in a lot of different places. And then we start seeing inline NIR that can be used, and it's still too expensive for most facilities to have it all over their facility, but we're getting closer and closer to that. And then we're taking it another step in some instances where we're not even just using it to measure nutrients. We're figuring out, well, if you grind a sample to different particle sizes, the NIR looks at it differently. It's why you got to be so careful when you grind it before you put it on the sample. Well, that means particle size has an impact on it. Could we use this to measure particle size? Can we use this to measure uniformity? And it sometimes feels in the moment like a very slow burn, but you look back 10 years later and go, oh yeah, 10 years ago I'd have said we can never afford to do this. And now someone figured out how to build that same camera for next to nothing. And it's that part's always really interesting. So kind of to, I think, both of your points, you kind of have to get interested in what's going on. And actually that's the question that I want to I think close out on. And we always try to do something at the end that gets into professional development or resources. But I think you guys could answer a really interesting question. And it's not just specific to your particular project, but overall, and we see this in academia, and I imagine it's true also in the industry. It's always easier, and that's true for, in many cases, funding and publishing and finding students and everything else. It's always easier to kind of do the next iteration of the basic science thing that we already know. Like, hey, let's feed some more cows and see how they grow better or whatnot. But you guys have chosen to do something that's, kind of high hanging fruit. You've chosen to do something that's high risk, high reward from the standpoint of we have no idea if this can even work. What's that like in the environment in which you work? Like what's exciting about that? And what would you say to others who are considering, low risk, low reward versus that high risk, high reward kind of thing of really getting into the future, I guess?
we have on this project, and we're also very interested in the adoption of this. So we have another collaborator, Linda Pfeiffer from Ag Sciences, Education and Communication. So in this project, we have faculty and students from at least 4 different departments: animal science, ag and biological engineering, electrical and computer engineering, and this social sciences of adoption in ASEC. Going forward in terms of professional development, all of us need to be really good at working in teams. When I know my language and my field, but I don't know yours, but I kind of need to for us to make progress. And we've had many conversations where something was really clear in one mind and kind of misunderstood, or maybe even not understood at all in another. And so that ability to cross-talk among disciplines is critical. You have to want to do it. And we are blessed with Jackie leading this and the team that we have, that everybody does want to do it. Like, there is good energy. That also is, I think, for the grad students, particularly and the undergrads, for them to witness that collaborative, energetic approach. Like, I think this is just a really good culture to build, but we're building that interdisciplinary culture. So, the use of tech and the application of it, that sort of thing.
Great.
And I would agree. I think that this has been just a privilege to be on this team and to learn. So I find myself thinking more like an engineer than I ever have. And I'm a nutritionist by training. And a lot of what I had done was incremental change to just get down to maybe understanding requirements more. And that is progress, but it is not giant progress all the time. So this has been a little bit uncomfortable based off of what I was trained to be, because we are trying something that may not work. And when I feed a cow, I know that I know what I fed them and I know what the responses are, and you can always write something about what happened. But when we're doing this, it's a lot of designing systems and trying to, it's iterations of things to try to get it to something that's usable. And it doesn't always work the first time, and then you have to redo. So it does take a different mindset, but I do feel like it's been just wonderful to learn about how other researchers work and how we can make progress by understanding our needs a little bit more and our capabilities.
Yep. Absolutely. And as the host, but someone who's also interested in these kind of things, I'm going to echo what you both just said. It's exciting to go do the hard stuff. It's exciting to go do the stuff that people haven't tried to do before. You will not be successful doing that if you aren't uncomfortable and if you don't have a good team. It won't work. And I think you guys have both just explained that very, very nicely. So I appreciate that. And I hope it's a lesson that the audience can take as well. I very much enjoyed our conversation. It's been a very quick half an hour. I think the project you guys are talking about is it's quite exciting. It's one of those things that I imagine could significantly have an impact on the industry, but also will have applications beyond what you're just doing in this specific instance. Looking at TMR, you figure out how to do this, it will apply other places, and I think that's really, really cool. So I appreciate both of your time today.
Thank you so much.
You're very welcome.
My guests today have been 2 faculty from Purdue University. Dr. Jacquelyn Boerman is an associate professor in the Department of Animal Science, and Dr. Dennis Buckmaster is a professor in the Department of Agricultural and Biological Engineering. Thanks again. On behalf of Wisenetics, I'm Adam Fairnoltz from North Carolina State University. Thanks a lot for listening. Thanks a lot for watching. Please feel free to like, subscribe, leave us reviews, let us know what else you'd like to hear about. And until then, we'll talk to you the next time.